Friends, today we are going to discuss non-homogeneous solution of non-homogeneous second order differential equation. In my previous video, I have discussed about the solution of homogeneous second order differential equation. Today we will discuss solution of non-homogeneous second order differential equation. So first of all, you have to know what is a non-homogeneous differential equation. Actually, what is the form of non-homogeneous differential equation? If we write d2y by dx square plus p dy by dx plus q into x equals capital R function of x, that is non-zero term in the right hand side, non-zero term at the right hand side, and the form of differential equation is such that d2y by dx square plus p dy by dx plus qx equals r of x. That is non-homogeneous differential equation. So then how to solve it? So step 1. So I am writing the steps. So solution. So whenever we will get a non-homogeneous differential equation, solution will contain two things, CF plus PI. You may now ask, what is CF and what is PI? So solution contain one part is CF, that is complementary function, and another part is PI, particular integral. So in case of non-homogeneous second order differential equation, solution will contain one is complementary function, another is particular integral, both. So complementary function how to solve I have discussed in my previous video. So today I will discuss method to calculate particular integral. How to calculate the particular integral? So let's start. So step 1 you have got step 1 of the solution of non-homogeneous second order differential equation. You have already got that y equals CF plus PI. So here method to calculate particular integral, that is PI. So case 1 is if that form d2y by dx square plus p dy by dx plus qx equals rx. If rx is given to you such as rx equals e to the power ax, this form is given to you, then particular integral will be 1 upon f of d, function of d, e to the power x. So if rx equals e to the power ax is given, so particular integral will be 1 upon f of d e to the power x. Now it can be written particular integral equals 1 upon f of d e to the power x equals, here a is here given, so you can here write substituting d equals a 1 upon f of a e to the power x. So for rx equals e to the power x, particular integral is 1 upon f of a e to the power x, where f of a not equals 0. So this is the first case. Now second case is that if f of a is 0. Second case is that if f of a is 0, then in that case particular integral and rx equals e to the power ax. Okay. So in that case particular integral will be x e to the power ax into 1 by f of a, f prime a means derivative of f of a with respect with respect to a, and f of prime a not equals 0. So case second is what? Second case is if f of a is 0, then you will get particular integral equals x e to the power ax into 1 by f of f prime a. F prime a is derivative of f of a, and f prime a not equals 0. Similarly, if f prime a equals 0, then you can write, the case 3 is coming then. If f prime a is 0, then you can write particular integral equals x square e to the power ax by 1 by f double prime a. Here f double prime is double derivative of f of x with respect, and f double prime not equals 0. So in such case you will proceed. So let us take an example so that you will be clear. So I am taking an example, d2i by dx square minus, let me write properly, d2i by dx square minus 3 dy by dx plus 2y equals e to the power 3x. So this is the equation you have been given, d2i by dx square plus p dy by dx. So p is what here? P equals minus 3 plus qy. Qy is given here to you. Here one thing I should correct now. So one thing I will correct, that it is d2i by dx square plus p dy by dx plus qy equals e to the power 3x. I am correcting that I have written d2i by dx square plus p dy by dx plus qx equals 0. That will be qy equals 0. Corrected. Q 0 not, here it will be rx, r of x. So d2i by dx square plus p dy by dx plus q of y equals r of x. So similarly, d2i by dx square minus 3 dy by dx plus 2y equals e to the power 3x. Now by comparing you will get p equals minus 3 and q equals plus 2 and rx equals e to the power 3x. So now solution of this differential equation. How to solve it? Let's start discussion. So whenever you will solve this differential equation, so first step, y is containing cf plus pi. Now cf, how we will calculate? Complementary function equals, first you have to calculate auxiliary equation. Auxiliary equation is m square minus 3m plus 2 equals 0, or you can write, you can factorize it and you will get m minus 2 to m minus 1 equals 0. So after factorizing you are getting m minus 2 into m minus 1 equals 0. So two roots you are getting, m equals 2 and m equals 1. So they are what? Real but unequal real but unequal roots. So for getting real but unequal root, what will be the complementary function? So complementary function will you will get cf equals c1 e to the power 2x plus c2 e to the power x. So you have got complementary function. Now you have to get pi, particular integral. Now rx equals what you have got? Rx equals e to the power ax. So particular integral you will get rx equals e to the power ax. So pi equals 1 by f of d e to the power ax. F of d equals what? A. Now here is the main question. How you will calculate f of d? What is f of d here? So in the question you have got one thing, d2i by dx square minus 3 dy by dx plus 2y. So you can write it in such a way, d square d operator, in the d operator format, d square minus 3d plus 2, where you have to assume that d equals dx and d square equals d2 by dx square. So f of d, it will be f of d equals d square minus 3d plus 2. D square minus 3d plus 2, this term you are getting. So d square minus 3d plus 2. So similarly here particular integral will be 1 by f of d e to the power x 1 by d square minus 3d plus 2 e to the power 3x. Now you can solve d square minus 3d plus 2. Now here a is what? A equals 3. So substitute 3 value here. Substituting a equals 3 here, you will get particular integral equals 1 by 3 square minus 3 into 3 plus 2 e to the power 3x, that is 9 minus here 3 into 3 9, 1 by 9 minus 9 plus 2 e to the power 3x. So particular integral you are getting half into e to the power 3x. So y equals complementary function plus particular integral, you will get c1 e to the power 2x plus c2 e to the power x plus half into e to the power 3x. So this is the complete solution of d2y by dx square minus 3 dy by dx plus 2y equals c to the power 3x. So now let us discuss another case. We will discuss the example in my next or any other previous video. So next case is such that another case is such that if Rx is polynomial of x, Rx is such that it is polynomial of x, then particular integral it will be 1 by f of d x to the power n. That means if Rx is given such a way that Rx is polynomial of x, then particular integral will be 1 by f of d x to the power n. Now what you have to do here? You have to do particular integral equals 1 by f of d x to the power n. You have to expand, rule is here, you have to expand 1 by f of d in series containing power of d, in the series containing power of d. And another case is such that if you are given Rx equals cos ax, first I am discussing all the case, then in my next video or any other video I will discuss the examples also. If Rx is given to you cos ax or sin ax. So in the previous case what you have got, that if Rx is given that polynomial of x, that is such as x to the power n, then particular integral will be 1 by f of d x to the power n, and you have to expand a 1 by f of d in series containing positive power of d, Similarly, in the next case, if we got Rx equals cos ax or sin ax, if we got such case, so in that case particular integral will be, if particular integral will be 1 by f of d square into sin ax or cos x, whatever. Now here it is a, so here after you have to substitute d equals minus a square, d square equals minus a square, not d equals minus a, you have to substitute d square equals minus a square. So 1 by f of minus a square sin of ax. So particular integral you will get 1 by f of minus a square sin ax. Here f of minus a square not equals 0. Now if such case is coming, f of minus a square is 0, then what you will do, if f of minus a square is 0, then particular integral will be x into 1 by f prime of minus a square sine ax. So this is the case for rx equals cos ax or sin ax. If rx equals e to the power ax phi x, such case come, then particular integral will be 1 by f of d e to the power x phi x. Now take the exponential left hand side, e to the power a of x 1 by f of d plus a, 1 by f of d plus a phi of x. So these are some cases how to solve a particular integral of non-homogeneous differential equation. Another case also come, that if you have been given r equals x sine ax, if you have been given rx equals x sine ax. So we'll discuss such cases in my next video. In my next video I will come with another video also, another topic also. So thank you for today. I will discuss more in my next or any other video about this example of this type of differential equation. So thank you for today. Bye.